Today, geometry, we are going to be talking about 6.1 perpendicular bisector and angle bisector. So let's start off with a kind of a review question that we should know by now. What does bisect mean? As we have gone before, we've bisected line segments, we bisected angles. When we bisect something, we cut it into two equal parts. So we cut two equal parts. Also, so then the next one, what does that mean to be the same distance? The fancy word for that is equidistant. Just like we have equilateral, which is the same length, and equiangular, which is the same angle, equidistant means equal distant. Distance. Okay. Our theorem: in a plane, if a point lies on a perpendicular bisector on a segment, then it is equidistant from its endpoints to of the segment. This is our perpendicular bisector theorem. So our perpendicular bisector says that if a point lies on the perpendicular bisector of a segment, meaning line segment, then it is equidistant from the ends of that line segment. So here they have here a picture of a perpendicular bisector. The point in which this theorem is talking about is this point here, point C. And the theorem says if it lies on a perpendicular bisector, and the perpendicular bisector is actually this line. If I make this orange, it's this line here. This is our perpendicular bisector. We know it's a line because it has the arrows here at the end, right? And then it says, well, then it must be equidistant from the endpoints of that segment. So the line segment that it bisects, is this line segment here in green. The endpoints of the line segments are A and B. So these are our endpoints in which they're talking about. So this is an endpoint and this is an endpoint. And they're saying since this line is a perpendicular bisect, C must be equidistant from the endpoints. That means AC has to be congruent to CB because that line bisects AP and PB. So first we need perpendicular, right? So if CP, that line CP, what we talked about, line CP is perpendicular to AB. We'll say line segment AB. And AP, that the for one of the segments, half of the segment AP to the other half, PB, then we can prove, we can say for sure AC that has to be congruent to CB. Those hypotenuse have to be congruent to each other. This is a hypotenuse of a right triangle, and this is a hypotenuse of a right triangle. Just like that. Our converse of that, right? So our converse of the perpendicular bisector theorem says, in a plane, if a point is equidistant from the endpoints, then it lies on the perpendicular bisector. So we can prove that this is a perpendicular bisector. So the point once that we're talking about is this is the special point. In this case, this here is our point, and they basically say, hey, if the two segments that's connected to those endpoints are congruent, then you are on a perpendicular bisector. So if AD happens to be congruent to BD, to BD, and point P and D. This way, this line here, it'll have to extend all the way through. P and D are on the same line. Then D is on the perpendicular bisector. Let's put this into practice. Okay, so let's actually figure this out. So in terms of perpendicular bisector, find RS. R and S. So I see here we have a perpendicular. I see I have two equal segments. I got some perpendicular bisector. So since one is 6.8, I know the other one, the other hypotenuse, also then has to be 6.8. Okay. Next one, find EG. Well, we have a perpendicular bisector. Remember, this is the points. And everything on one side must be congruent to the other. Since 24 is congruent to 24, 9.5. EF needs to be 9.5. They want EG. EG is the entire length. So EG must equal 9.5 plus 9.5. That gives us 19. Number 3, find X and then find CD. So perpendicular bisectors, as you remember, one hypotenuse must be congruent to the other. I'm going to set them equal to each other to solve, since they have to be congruent. I'm going to subtract 3x to both sides. Get 14 equals 2x. Divide both sides by 2. X should equal 7. So I got 7 for x. I'm going to take that, and I can plug it into either side since they have to be congruent. I'm going to say 5 times 7. Actually, they want CD, but CD and AD. I'll just plug it into CD then. CD is 3 times 7 plus 14. 3 times 7 is 21 plus 14. That gives us 35. So CD should equal 35. Let's go on, see what else we have for us. Okay, another theorem with perpendicular bisector. We are now dealing with angle bisector. So here, this is an angle bisector. So my angle bisector theorem says if a point lies on the bisector of an angle, then it is equidistant from the two sides of that angle. Okay, so the angle that we're talking about is, I'm going to highlight this in green. This is the angle that we're working with in green. The point that we're talking about in this theorem is this one. This is our point. So if AB, right, ray AB is perpendicular to BD, line segment BD, and AC is also perpendicular to CD, and angle BAD is congruent to angle DAC, then we can say BD has to be congruent to DC. So BD here is congruent to BC according to our angle bisector theorems. So there's a lot of things that have to happen. We have to have perpendicular angles. That point has to be perpendicular to those two sides of that angle. the green angle right there. And then because of that, if it is perpendicular to both sides, then we can say that their segments BD and DC is congruent. Converse to that, converse to our angle bisector says that if a point is in the interior of an angle and it is equidistant from the two sides of the angle, then it lies on the perpendicular bisector. So we can prove perpendicular bisector because it is equidistant from the two sides of the angle. It is. So here, this is the point that we're talking about again. So if D is on AD, ray AD, and BD is congruent to DC, then AD is the angle bisector of angle BAC, the big angle right there. So let's put some of this into practice right here. So angle bisector, but just basically saying one angle has to be congruent to the other. So if one angle is 42, I guarantee you the other angle also has to be 42 degrees. And it says find the measure of angle GFJ. Well, GFJ is what, 42? Let's see here. Number 2, they want us to find X and find PS. So this, once again, these two have to be congruent. So we just got to set them up, equal, and solve. So 5x must equal 6x minus 5. I am going to do something different that I don't normally do. I'm going to subtract this 6x first. This becomes negative x equals negative 5. Divide by negative 1. X should then be just plain old 5. I'm going to plug that back in to find PS. PS equals 5x equals 5 times 5, which is then 25.